In programming, the concept of selection is a fundamental aspect of program flow, allowing a program to make decisions and execute different blocks of code based on conditions. This decision-making ability is essential for enabling interaction between the program and the user, as it allows the program to respond dynamically to inputs or varying circumstances. For example, in an application where a user enters their age, the program might need to determine whether they are eligible for certain services or discounts, which requires evaluating the input and selecting the appropriate action. The most common mechanism for implementing selection is the if statement, which follows an if-then-else structure. This structure begins by evaluating a condition within the if clause. If the condition is true, the program executes the block of code following the then. If the condition is false, the code within the else clause is executed, providing an alternative outcome. For instance, in a program that checks whether a number entered by the user is positive or negative, an if statement might look like, if number's 0, then print positive, else print negative. This straightforward logic ensures that the program handles both possibilities appropriately, guiding its flow based on the user's input. When decisions become more complex and involve multiple levels of evaluation, nested if statements can be employed. A nested if statement is simply an if statement contained within another if statement, enabling the program to handle multiple conditions and produce various outputs. For example, in a grading system, a program might use nested if statements to determine the grade based on a user's score. The outer OR if could check whether the score is greater than or equal to 50, indicating a pass. Within this block, another if could evaluate whether the score is above 80 to assign an A grade, while an else might assign a B. If the initial condition is false, the outer else could handle failing scores, assigning a grade of F. This layered structure provides a way to deal with scenarios requiring hierarchical decision-making. In cases where there are many conditions to evaluate, using else-if statements can simplify the logic and improve readability. The else-if construct checks conditions sequentially until one is found to be true. Once a true condition is encountered, the associated block of code is executed and the remaining conditions are ignored. This approach is efficient and eliminates the need for deeply nested logic. For example, in a traffic light control system, an else-if structure might evaluate the current state of the light and decide the action for a car approaching the junction. The program could first check if the light is green and print go. If not, it would check if the light is yellow and print prepare to stop. If neither condition is true, it would default to printing stop for a red light. This method ensures that only one condition is met, and the program flow remains logical and orderly. Another way to implement selection in programming is through the case statement, also known as switch in some languages. A case statement evaluates the value of a variable and executes the code associated with the matching case. This is particularly useful when dealing with discrete values or categories, as it avoids the need for multiple if or else-if statements. For instance, in a program that calculates the days of the week, a case statement might evaluate a variable representing the day number. If the value is 1, it would print Monday, if 2, Tuesday, and so on. A default case can handle invalid input, ensuring the program behaves predictably even when faced with unexpected data. This approach is clean and efficient, particularly for applications involving a fixed set of potential values. Selection constructs such as if, nested if, else if, and case are vital tools in programming. They enable a program to interact with users and adapt its behavior based on input or circumstances. These constructs provide the flexibility to implement complex decision-making processes and ensure that programs respond dynamically and logically, creating a foundation for interactive and functional applications.